Yeah, good day YouTube. Some of you people complain I'm not making enough videos for you. However, it's not so easy making new videos. I have one thing though. Finally I managed to buy myself a logical analyzer, one that is well worth the name logical analyzer, and to me it's doing a good job. However, it's a Windows logical analyzer and the software is Windows only, so I had a few issues to resolve. One of them issues would be getting the USB support working in VirtualBox, since I have no native Windows installation, which has proven to be, yeah, a little issue here. However, the logical analyzer I've gotten is the Logian. Well, Meilhaus is a German company and so it's a German product. I don't know the availability in other markets, USA, whatever. But and those logical analyzers are sort of expensive. This is one in the middle price range with the probes. I bought myself a couple of additional probes, very fine probes, and grabbers. I mean, those are one of these high precision grabbers. All in all, $400. And the next higher model, which would be 200 megahertz. I mean, this logical analyzer has 16 channels, and that's probably read by the name, 16 channels sort of, and 100 megahertz of sample rate, which for my purposes is enough. So let's hook this thing up and do a little measurement, just to prove the case what a logical analyzer would be good for. Yeah, what is it good for anyway? It is it's a digital oscilloscope, and it's PC based because you have standalone applications like in a mixed signal scope, but those are very expensive, and you see that a PC based solution has a variety of advantages like protocol analyzers, which make the thing as useful as it actually is protocol analyzers anyway. I mean, without them you can do all the analysis sort of by hand, manually, and this negates the point of a good logical analyzer a little. So I'll show you how it works. By example, I have on this board various ICs, like the network IC, which is controlled by the MCU with, well, it's SPI, the serial peripheral interface, and I have this real-time clock, which is I2C, two-wire interface. Let's analyze a few of the little pieces of the communication between the real-time clock and the MCU. Why would you do this? Yeah, sure. Once everything works, you don't have a problem, but while you're developing the stuff, you're not always so sure whether everything is just the way it is supposed to be. Like in, I'm reading shit from this clock. Is it just the clock? Or is it my software? Because you should never forget that you need to write software that is namely a driver to get this thing working, and there's a range of possible problems here, ranging from the software itself or the hardware. I hope you can see this. Putting this to the ground, because you should always attach ground. So you have to attach the probes. Those are standard probes, although for standard probes it's good probes. I mean, those are not exactly inexpensive, although there are finer probes like these. I switched the circuit off while I'm hooking it up because you know, this is always better when fooling around with your circuit. Turn it off so you prevent any accidents from happening, like short circuits or whatever kind of stuff that could make your experience worse. Okay, you should always hook up the ground level. I think I have ground on one of those. Look, that's a certain. I have this connector here, which is supposed to be housing extension boards, and there's the I2C bus already hooked up. I could do this directly on the IC, but doing it directly on the IC, those would be better, but the standard probes are quite fine with that. And I have the two bus logic. I mean, I2C has two lines. One is the clock line, and the other one is the actual data line. One is called SGL for clock whatever, and the other is SDA. So the red one would be the data line. Okay. Turn it on. What we would need next is our software. Let's go back to our PC for that. Let's go back here. Yeah. Yes, the PC. And I would appreciate if you don't make any dumb comments about what background images I use or stuff like that. I mean, that's not certainly not what I'm making videos for you guys for. For these kind of bullshit comments I certainly won't need. Thank you for that. Okay. It's Windows here. I mean, sort of. Software is Windows only, so I have to use a Windows machine. Bring up software, and I hope you can see this now. Let's check this. Yeah, it's good enough, I suppose. This is the software for the logical analyzer. I hope you can see anything. Yeah, it's always a little problem here, but I think it's good enough. So what I can do is on the first bus, those are the bus signals here, and I do a trigger here on the low level because and I have can push the button which would trigger the thing once the signal goes low, because on I2C it's always so that the high signal here being at high means it's idle, and since there's only 1 second little event on this bus, I have to do a trigger, because if I don't, yeah, well, that's not exactly, it would be a long time of no activity, and this is not what we want to do. So what we can do now is group this thing into a bus. I say group into bus, and then I have to say what protocol it is, and this is one of the things of this logical analyzer which bugs me a little. Basic protocols, this includes I2C and SPI, thankfully, have to be registered and paid. Well, it's extra, it's a premium functionality which costs extra money, so you have to register it, and it has a very crummy website, and it's, you know, it's no pleasure doing this. I haven't even figured out what kind of a code I have to input there to get it working. Actually, it's very crummy, but I say bus property, so I activate the protocol analyzer and say this is an I2C module. Okay, so let's do this again, hopefully. No, I don't think this is what I need. Probably the other way around. Yeah, the other way around, because now I have let's do this a different kind. I can of course say it's not right. It says this crap here. I have parameters config, and I say that A1 is SDA for data, I suppose, and CL for clock, and it's the other way around. Everything else doesn't make a lot of sense here. Yeah, no, next one. more sense. Let's do this again. Okay, it's just an example of what you can trigger here. Okay, now you have to understand the protocol a little. I don't want to go into this protocol also too deeply. I just want to show the logical analyzer and what it can be used for. There's a start condition, there's a stop condition, and there's always, when you do something, an address. In case of this clock, for example, this real-time clock I'm using there, it's a hard-coded address. Sometimes you have devices, that is ICs, that can configure the clock line to a certain number of different addresses, so you can attach more than one device to a bus, because this is always a problem. I could attach only one of those devices to a bus, since unfortunately for many of those devices it's hard-coded. And this is a hard-coded address, and that is always an acknowledgement. And yeah, this is the clock line. As you can see, it's 15 microseconds, 10 microseconds, 20 microseconds. Yeah, that's just about. You can configure the speed of this thing. This you would do in your AVR firmware, and depending on what device you use, you can make it a little faster, a little slower. So it's sort of it's 200 kilohertz of sampling rate, as you can see, and the module says this right, acknowledge, and there's data, and then yeah, and then there's stop, there's start, and there's address again, the same address, and then it's a read, and that's an acknowledgement, and then it's data again. Yeah, this is just about what happens on the bus. Yeah, I should do 16, and let's run it again. There's always this trigger. Okay, now I have one cycle of this thing. What actually happens on the bus is, of course, dependent on the software, on the firmware of your car, or whatever, on your AVR, and this already works. It's just an example of how to use the protocol analyzer. And there is some a window that a bus packet list. Alright, that's something that is interesting. See, it's 17, 18, it's 17, what's the clock anyhow? 17, 17, and then this is data I read from the clock. Not going into details here because it would negate the point a little. But with the protocol analyzer running here, at least you see here, this is the packet list. It's already decoded, so you have your two bus signals here. The one is the clock line, and the other one is yeah, the data line. And with this protocol analyzer and this module you have in the software, which is a Windows software, I told you already, but I'm running this thing in Linux with VirtualBox. And since I finally figured out how to get this crummy USB working, it's working. And you have this tool which on the bus tells you what. It's always the same address. It's 68, but this is hexadecimal. And the bus packages which are, let's start it again, should change. Yeah, that's changed here. 1720, this is the actual clock. It's 1720. 17 is the hour, 20 is the minute, and some read the date as well. But the date is a little packed. 20, this is the year 2000, and let me get this right, 2012, which is the year, and I have to do this in two data packages. I mean, you have to consider the driver. This is all hardware level, so but 1724, this is probably the second. If I start this again, this should change. Yeah, 1720, 56, 21 is now. It reads 21 on my clock. So 1721 and 4 seconds. This is what I read from the real-time clock, and this is how it looks on the bus. And there is, let me, yeah, like this. You can zoom out. This is how it looks like on the bus. I mean, this is how it looks like on the peripheral bus on signal level, and this is the interpretation on protocol level, which is very useful if you want to do any kind of debugging concerning your software or whatever. Mainly, do you have a problem with the device itself? Does it work correctly? Does it send the right data? And do you send from the AVR? I mean, this is, I mean, the stuff I send, like all the commands and the address, this is all stuff you have to send from your microcontroller usually, and it also needs to be right. And if it isn't right and the whole thing isn't working, you could figure it out by just analyzing the bus here. Yeah, I have with this project few issues to resolve. I mean, don't get nasty on this. I really want to get this finished, and I want to get it working well. This is one of those projects I like to really work well. It's some sort of my personal, I mean, it's one of the projects I really like to get working well. And yeah, show you protocol analyzer once more. I mean the logical analyzer, which is here. That's dark, isn't it? It's Logian. I don't really know the availability on the US market or anything like that, since, yeah, I'm glad that this is working for me. And this was about, with the probes, about 400 bucks, which is good price for a tool like that. And I have the software, which is Windows only, I'm afraid, but still it's at least fitting for my purpose, and it has protocol analyzers and all that. If you have, say, if you do it with a standard oscilloscope, you would have to interpret all those things that the protocol analyzer is doing for you here. You would have to figure this out all by hand. Like, you see the signal here, and toppermost line, which shows you all the status, stop, and address things. This is already the protocol deobfuscated, and you would have to figure this out all by hand, which isn't exactly a nice thing to do, and it's error prone if you have to analyze the signals just sort of by hand. So it's very well if you have this a tool like this handy. So logical analyzer is always a good tool for developing hardware. And yes, I have I have one new project plan, which would be a better version of the, you know, what should I call it? It's a sensor probe, but this time with Ethernet, and more stable and all, and more features and more sensors, and I think I would like to have the next project done with an ATX microprocessor. I mean, with those new new. I mean, it's not also new, but I would want to do it with an X meter. Yeah, well, thanks for watching, and yeah, if you have any suggestion about what I could do for you in videos, please don't ask me about things like show me your computer or stuff like that. I mean, that's certainly worth the while for most of the people. I mean, my computer isn't all that special. Something that is a little more to the topic. Thanks for watching, and see you soon, I hope.